Hi, in this video let's talk about backpropagation, and this is one of the most important algorithms there is in deep learning. Okay, so till now we have studied that in deep learning we use a network of neurons. Okay, so and we try to mimic the human brain. Now what happen actually is neuron in itself just cannot do all the processing. We need some activation functions for that. Okay, and in the first iteration even the activation functions cannot just predict the right value. Okay, so we need to keep on training our neural network, okay, to predict the correct output. We have to keep on analyzing if our performance of the model is good, and then we have to keep on training that. The backpropagation is the algorithm that is used to train the neural network. Okay, so for example, or before starting with the backpropagation, let's look at one of the examples. Let's look at the following house prediction model, house price prediction model. Let's see that. So in this model, we are predicting the price based on the number of bedrooms and the floor level of the house. Okay, and this is in $100,000. This is in $1,000 basically. So 300,000, 400,000, 500,000. Okay, so let's consider the first case that we have is a BHK is 3, floor is 6, and the price is 300,000. If we construct the neural network for this particular data set, then since number of features we are having is 2, we will have 2 input layers. Then we have some weight associated with all the connections. We have hidden layer. We have just one hidden layer right now, and the number of neurons that we have kept is 2. Okay, and since the price is one thing, the price is just one feature, one target we have, so we just have one neuron in the output layer. Okay, so since we are interested in the price, we consider the activation function to be linear. We have just considered the linear activation function. All right, so our current output is going to look something like this: y is equals to wx plus b, because the activation function that we are using is linear. So whatever is the input is the output plus some weights and bias. All right, and the graph is going to look like this. And why the graph is looking like this, you can actually refer to the video where I had explained the role of bias. Okay, now here we have only one hidden layer with 2 neurons with bias b. All right, now let's make the first iteration. So in the first iteration, what we do, we randomly generate weights and bias, and we randomly assign the bias. Okay, so this is the table to assign the weights, and this is the table to assign the bias. We have generated the weights randomly. So the weight from input 3 to the first neuron is 2, and to the second neuron is 4, and similarly we have assigned all the weights and all the biases that we have provided. All right, 1.5 and 2. Okay, now the output, we will try to generate the output, and output will be generated using this function, which should be clear. Okay, so we have the output as w1 x1 plus w2 w1 x1 plus w2 x2 plus b, right? W1 x1 w2 x2 plus b. So we have generated the output, and once again here for this output we are also doing the same thing. We have w1 x1 w1 x1, then we have w2 x2, right? And then we have the bias 2, and this is the output that we have generated. Now once the output is generated, what we do, we calculate the error in our prediction. Okay, and the error is given by actual minus prediction, which is in our current case the actual prediction should have been 300,000, right? So the error is 57.5 right now. By the way, the process that we just did is known as the forward pass. Basically we are moving forward with our calculation. Now once we have calculated the error for the first iteration, and the first thing is that never expect your model to be perfect in the first iteration. There is no model that is ever perfect in the first iteration. And the point of neural networks or point of using deep learning or machine learning is that we make error, we keep on making error, and our model keep on learning through those error. All right, so now is something very beautiful that comes into the play, and that is we have iteration 2, and in the iteration 2 we perform back propagation. Okay, now depending on the magnitude of error, the weights and biases are adjusted. As you had already seen, the entire input or the entire output equation, whatever the output we have generated here, was entirely based on the weights and biases that we have provided. Okay, the input we cannot change, but the weights and bias is something that we can change. So what we do in back propagation, based on the magnitude of error, we adjust our weights and bias. Okay, so basically we back propagate, we provide the feedback to the previous neuron, and the entire weights and biases are updated using this process. Now the formulas that we use to update the weights and biases is this: we have the previous weight here, we have the previous weight, and then we have the error, we have the partial differential of the error that is generated because of the previous weight. Okay, and this is what gives us the updated weight, and we update those weights, into our model. Okay, so now we have new weights and new biases generated. This is the weights and this is the weight, and this is the bias of the previous iteration, and this is for this new iteration. And as you can see, we have updated all the weights and biases right now. Then we recalculate w1 x1 or w2 x2 b1. We recalculate all the outputs, and at the end we get 276.76. okay, now we recalculate the error. Now the error comes out to be 23.24. This above process will keep on going on until the error is reduced to the minimum extent. Okay, until the error is reduced to the extent which is bearable, this above process keeps on continuing. So this is the entire process of back propagation. What happens? We are having a model, we create a sample neural network, then we randomly assign weights and biases, and then we calculate the value, then we predict the value basically, and then we see what is the error we have, and then based on that error we adjust our weights and biases, and then we recalculate, then we again adjust, then we again recalculate. So this is the process of going back and forth is actually called as back propagation, the process when we adjust the weights and biases. Okay, so if I have to give you a basic overview of the algorithm, we have sample label data. Okay, then we forward through a network of predicted values, through a network to predict values, then we back propagate the error, and then we update the connections, and this process keeps on going on. Okay, and by the way, this process of updating the connections and weights is what we call as training the network. Okay, now here we had just considered the first row of the data set, and yeah, this is the good point, that right now we had just considered the first row of the data set. Okay, we had just considered this row of this data set. Okay, and there are at least thousands of rows right here. Okay, so here we had just considered first row of the data set, but actually the entire data set is considered and used to train the model. So imagine the amount of improvement it will have in each iteration, because number of outputs will be contributing to predict the error. And in such cases, when we have number of outputs and we have to take a aggregate measure of error, we use this formula where we have the summation of all the errors, and the errors are actually taken as this square. Okay, so this is the formula that we use, and this basically term is called as the consolidated error. The collective error is calculated, and then W and B are updated once for each iteration. Now doing that, the model gets trained for the entire trend of data, not just for a few rows. Okay, that is the thing. Now if you just if you just train it for just a few records, then it will be trained for a few records. But if you train it for the entire data set, it will understand the trend of your data. Okay, so the better the model will become. So if you do something like this, if you train using a deep learning model, then your data will go from looking something like this to looking something like this. Okay, earlier the regression was linear regression, and now you can see that our model is actually fitting our data very nicely. Okay, so stacking and processing more complex function using neural network. This is the line of best fit obtained by neural networks, and this is the line of best fit obtained using linear regression, which is actually a machine learning algorithm. Yeah, so this was one part about backpropagation. In the next part, we will extend our discussion in the backpropagation.